Hello students, I hope you're doing well. I just want to take some time to talk to you about Supplemental Lab 3.1. And in this particular lab, what we're doing is we are doing several different experiments. We're just sort of proving Ohm's law actually works. And so we're going to be dealing with these three resistors. And our first experiment here is we are taking these three resistors and we are just moving the current meter around. So we're putting the current meter between R1 and the power supply, and then moving it between R2 and R1 and R2, and then we're moving it between R2 and R3, and then we're moving it between R3 and the negative end of the power supply. And so while we say current is constant, so if I measure current anywhere in my series circuit, it should be the same current. So that's what we're proving to ourselves in this. So we're going to take this circuit, and I've got my 820, my 560, and my 470. So here's my 820. And I'm going to build this just sort of the way it looks. We got that, and I got this. So there's my circuit there. If I look at that. So there's my circuit there, and let me do the first setting. Is I'm going to set my power supply. We're going to set that for 6 volts. Then I'm set for 6. And so I've got this set right at 6 volts, it looks like. Let's see. And I'm going to change that to 10 volt scale. And so here's my 6 volts right here. So I've got that set for 6 volts. Let's turn that power supply off. And I'm hooking my power supply leads up here. And my power supply is turned off, so anytime I'm doing any type of changes from resistors to, if I'm changing my resistor or anything else in there, and I'm going to try to drop this down a little bit. So anytime I'm doing changes, I turn the power supply off. So here we're going to set this to measure current. Set that to milliamp. And then my first position is I'm going to disconnect it there, and my meter is going to be at the top end of the circuit. So let me turn my power supply back on, connect to the meter, and there's my reading, 3.25 milliamps. Okay, so now we're going to turn the power supply off. I'm going to rebuild my circuit. And now I'm going to insert my meter where this gap is here. So positive closest to positive, and negative closest to negative. So let me turn my power supply back on, insert my meter. Oops. And reading 3.25 milliamps again. So turn my power supply off, rebuild my circuit. And then insert my meter between these 2 points here. I'm just moving my meter down, keeping positive closest to positive, negative closest to negative. So I'm just inserting my meter in series. And there's my 3.25 again. Get a good look. There we go. So all we're trying to do in this lab is that we are taking our meter And we are moving our meter from one position to the other and just proving to ourselves that our current is constant in this circuit. The next experiment we do is I have a variable power supply and a current meter and a resistor. So what I'm doing here is I'm changing my resistance and I'm measuring current. So if that's the case, when current goes up or when voltage goes up, current goes up. And so that's what we're doing here. We're just seeing that we go from 1.5 to 3 to 4.5 to 6. And as we do that, my resistance stays the same and my current changes as I go up. So you're going to prove to yourself that as voltage goes up, current goes up. Is that current is directly proportional to voltage. And then finally, we're going to take an experiment where we adjust the resistance. So instead of us adjusting or changing out resistors, we're going to take a potentiometer, okay? And this potentiometer has 3 terminals on it, okay? So there's terminal, commonly we call this terminal 1, 2, in the middle, and 3. And on the back of this potentiometer, sometimes we normally refer to this as a pot. If on the back of here you have some signage on here, but you can tell as it says right here that this is a 10K pot. So that means the maximum reading on this resistor is going to be 10K. So imagine that in this potentiometer is that there's a semicircle that goes around with resistive material behind this housing. And this middle one is the wiper. And so the wiper moves around. And so between terminals 1 and 2 you have a resistance. And between terminal 2 and 3 you have a resistance. But the total resistance of all this potentiometer, if I were to measure between 1 and 2 here, is I measure 10K on these outside terminals. But if this was halfway, I'd measure 5K ohm here and 5K ohm here. If I measured 2K ohm here, the other 8K ohm are here. So what changes is between the middle terminal and the outside terminals. So you're going to adjust your resistance to 500 ohms using your potentiometer, and then you change it to 1K, and then 2K, 4K, and 8K, and then you take your current reading. So that's what we're doing with this. So we're doing the experiment where we prove Ohm's law by moving the current meter around to prove that current is constant in a series-only circuit. We increase voltage and see that current increases, and then we increase resistance and see that current decreases. So all 3 of these are proving Ohm's law by definition that says that current is directly proportional to voltage and inversely proportional to resistance. So when I see you in class and you do this experiment, we're going to prove all that stuff and sort of bring home all the things we know about Ohm's law. I'll see you in class.